Okay, let's start with another polynomial simple rational expression. And this time we are going to simplify top and then bottom. So if I look at my top, I have a binomial and it's a difference. And if I take a look at the y squared and the 16, they're both perfect squares. So I know this is a difference of two squares. So I know that I'm going to have two binomials, and the square root of 16 is 4, so I know I'm going to have a positive 4 and a negative 4. And then on the bottom, this is a perfect square trinomial, and I have y. And what can I multiply to get 16 but add to get negative 8? Well, that would be negative 4. Okay, so now my numerator and denominator are both simplified. Now what I want to do is look for similar terms, top and bottom. And I notice I have a y minus 4 and a y minus 4 binomial, so I can cross those out because they equal 1. Nothing more that's the same. So my simplified expression is y plus 4 over y minus 4. And my excluded value here, or what would make my denominator 0, is 4. So y cannot equal 4. Okay, there's another situation where we might have opposite binomials. So let's take a look at that. Let's say we have 2x minus 10 over 25 minus x squared. We're simplifying. Again, we're going to start by simplifying the numerator and then work on the denominator. So let's start with the numerator. It's a binomial, so I want to look for a common factor, the GCF. I notice that between 2x and 10, my GCF is 2, so I'm going to factor that out. 2x divided by 2 is x minus, and 10 divided by 2 is 5. No more common factors can be factored out, so I know that I'm finished. And now I'm going to work on the denominator. Like previously, I noticed that this is a difference and that 25 and x squared are both perfect squares, so this is a difference of two squares. So I'm going to factor it as such. I know I'll end up with two binomials. The square root of 25 is 5. And the square root of x is x, and so I'm going to have a plus x and a minus x. At first glance, it appears as if maybe we don't have any common terms that we can factor out. Or you might say, oh, well, there's a minus sign here, and there's an x and a 5 and an x and a 5, so I can just cancel those out. You can't do that, though, because subtraction is not commutative. So this is not the same as saying, oh, well, 5 minus x is the same as x minus 5. We actually have to do something with this first. These are opposite binomials. So I want to make this one look like this one before I cancel them out. In order to do that, I'm going to factor out a negative 1. So my numerator stays the same. I'm not doing anything with that. My 5 plus x, I can leave it like that. Addition is commutative, and it drives me nuts to have the variable on the right side, so I'm just going to rewrite it using the commutative property. I'm going to factor out a negative 1 from this, and I'm going to bring it all the way to the front of this expression. And when I factor out a negative 1, that 5, that positive 5, divided by a negative 1 becomes negative 5. And that negative x divided by negative 1 becomes a positive x. So now, because I have factored out that negative 1, I have two binomials that are the same. Now I can work on canceling them out. X minus 5 divided by x minus 5, well, that's 1, so I'm going to cross those out. And all of this equals what's left on top? 2. And you have this negative 1 here, so that makes the entire fraction 1. So I'm going to bring out that negative. The 1 will become invisible. So this is a negative fraction. And on the bottom it's an x plus 5. So again, this negative 1 is the same as saying 2 divided by negative 1, which is negative 2. I'm bringing out that negative to the side of the entire fraction. And this right here is the simplified expression.